In this video, we'll guide you through the process of inspecting an ore pass. Our main goal is to gather data that will prevent any production slowdowns. Depending on the reasons for the inspection, your flight plan might vary. However, the general preparation steps remain the same. The key factors that change are your flight speed and the number of flights required. There are typically 4 objectives in an ore pass inspection: getting a global overview of the ore pass, local wear areas inspection, hang-up inspection, and high-accuracy mapping. The general overview, this type of inspection, provides a broad view of the ore pass. You won't be searching for anything specific, you just want to have a general overview and a point cloud of the ore pass. The local wear area inspection. In this scenario, you already know the specific area you need to inspect for wear or geological deformation. The hang-up inspection, in case of blockage in an ore pass. ELIOS can be used to quickly locate this blockage. And finally, the high-accuracy georeference point cloud. Now, let's assess the risks associated with ore pass inspections. Regardless of your objective, certain risks remain consistent. As we already detailed all the risks in the introduction video, we will expose them very briefly here. Let's start with those related to pilot safety. Falling rocks. Make sure the pilot is in a safe area or behind a protective vehicle. Falling in the ore pass. All safety protocols must be followed, and the right protective equipment must be worn to avoid falling hazards. Remote control harness should not be worn when using a range extender, and its cable should be secured on a non-moving object. Human safety risks can be significantly reduced by using a range extender placed under or within the ore pass, ensuring the best possible connection while keeping the pilot out of harm's way. Rocks falling on the drone. In a vertical ore pass, one way to reduce this risk is by clearing the area around the top of the pass before the inspection. It can be done manually or by doing a small flushing of the ore pass. For inclined ore passes, the drone's flight trajectory plays a role, flying close to the ceiling, reducing the risk of rock damage. Water dripping. If the ore pass is too wet, it might be impossible to fly ELIOS. If there are just some drops, find the drier part of the ore pass to fly in. If conditions allow, it's best to fly when the ore pass is dry. The time of the day may have an impact. Strong airflow can complicate the flight and reduce flight time. If possible, try to limit this airflow. If not, fly against the wind to make sure you will be able to fly back. Dust in the ore pass can limit visibility. If there's no airflow, consider flying from the bottom up for better visual data. With strong ascending airflow, starting from the top can help the dust rise away from the drone. In humid and warm environments, fog can affect equipment visibility. Allow the drone to acclimate for 5–10 minutes outside its box before the flight. Once you've decided on the type of inspection, the blueprint becomes crucial. It provides essential information about the asset's size and geometry, guiding decisions regarding the pilot position, the need for a telescopic pole to place the range extender, or other techniques to reach the same goal, the use of a protective vehicle, and the placement of geo-referenced, reflective targets before the inspection. The ore pass we are mapping is 150 meters long and initially 3 meters in diameter. We will do a mapping flight, but without reflective targets, as we don't need to geo-reference this model. We'll follow standard mapping flight practices, maintaining a drone speed of 1.5 meters per second horizontally and 1.3 meters per second vertically, which is the maximum flight speed in assist flight mode, and avoid as much as possible collisions. Our flight plan will be to execute an H-shaped turn right after the takeoff, and then fly through the grizzly trying to avoid contact with it. There are often debris and hanging objects in the grizzly, so we will quickly fly down 2 to 3 meters under it. Then, we'll fly steadily in the middle of the pass down the ore pass. At the maximum descending speed in assist flight mode, it will take 115 seconds to fly down 150 meters. So we do not need to rush, but we don't have too much time to stop on the way either, if we want to cover the full OR pass. As we are using the LiDAR Rev 7, which has a longer range and point density, we just need to do 2 360 turns on the way down. Once we reach the bottom of the OR pass, we will then fly up and out. The total flight time should be approximately 5 minutes 30. As the up and down flight should take 4 minutes, we can add 2 times 30 seconds to fly through the grizzly and another 30 seconds for the takeoff and landing. If rocks fall on the drone during the inspection, we might not be able to recover the drone or the data. For this reason, we plan to download the flight data between each flights if we do more than one flight. There will also be the tablet recording, but it only allows you to see what the pilot could see during the inspection. After completing the flight, import the data into Inspector and process it using Faro Connect. Load the bag file, the JSON file, and select the tunnel captured environment. Once processed, you can view your high accuracy point cloud. Keep in mind that each inspection and OR passes are different and can have different risks. We are sharing here good practices, but you need to do your proper risk assessment and evaluate if ELIOS 3 is the right tool for the job. We hope you found this video informative and helpful for your future inspections. If you have any questions or need further guidance, please don't hesitate to reach out to the FLYABILITY training team.